So this is going to be a slightly different video than the usual kind that are on this channel, um, which, I just try to go over objective scientific evidence and give a little commentary, but try not to speculate too much. This video will be complete speculation, complete opinion, complete speculation with no real basis in any real data other than kind of an educated guess. Because one of the most common questions I get asked by my friends and other people is, when is this pandemic going to end, or how's it going to end? And I have an opinion on that now. At first, when this thing started, I kind of thought that we would get a vaccine out fairly quickly, and once everyone got vaccinated, it would end. That seems like that is unlikely to be the case at this point. And the other way it could have ended is if we were able to stop transmission before it became too widespread, as in the case of SARS-1 and MERS. If we could keep numbers, down in the hundreds, we could have basically eliminated the virus from the world um, as a practical manner and essentially eliminated thing. But we passed that threshold, over a year ago, back in January of 2020, when it became widespread. And now the thing is, it's global. Um, billions of people have it, and we're not likely to eliminate the virus. The Our only hope of eliminating the virus, or getting massive control over it, would have been if the virus stayed genetically relatively stable and we were able to vaccinate a large majority of the world population and achieve quote herd immunity from it. That seems unlikely to happen, as new variants come out that are clinically relevant, and especially the the B1 351 from South Africa, and the Brazilian one, and possibly a new one from California. These all have mutations that seem to make them less uh, make the vaccines less effective at controlling them. And I suspect this is just the start. I suspect that as vaccine rollout occurs, and the we apply selection pressure to the virus, and the virus is all over the world. There's a lot of genetic diversity to be exploited and to be used, as billions of people are infected. I think that we'll see variants that are even better at escaping the current course of vaccines. And this is not like the flu, where in the flu there are specific changes in the hemagglutinin and neuraminidase surface protein of the flu, and they can try to predict which flu will be the dominant flu in the next flu season, and kind of preemptively make a vaccine for the next season. And sometimes they guess correctly and it's very good, and sometimes they guess incorrectly and the flu vaccine is not very good for that season. This is not like a recombination of the hemagglutinin and the neuraminidase of the flu. This is just random mutations in the spike protein and other proteins in the virus. These are not predictable, and we can't guess what the next variant is going to be and preemptively make a vaccine. And then once you make it, a global rollout of the next vaccine, likely the virus will mutate again and escape whatever new vaccine we make. So, we'll just constantly be in this thing where we're chasing our tail. So I suspect this is not going to end in that way. I'm going to mainly make this video just so I can come back in a year and see how wrong I was. But I think that what's going to happen is that eventually the people that are most susceptible to the virus, unfortunately, will succumb to it. And then the people that are left will be the people that are either healthy enough to survive the virus, or their genetic makeup is such that their immune system does not overreact to the virus. Because there are some young, healthy people that succumb to the virus, and it is likely because something about their immune system makes them react, kind of overreact to the virus. And those people, if they're exposed to the virus, are unfortunately not going to do well. And so over time, there will be less and less susceptible victims to the virus. And over time, um, because the population of the host, um, which is us, the population of humans that are susceptible to severe disease will decrease, it'll become um, less of a problem clinically. And eventually we'll just get used to it, and we will tolerate it like any other endemic virus that we have. Luckily for us, from a purely objective standpoint, COVID is not extremely fatal with a fatality rate of less than 1%. If this thing was a fatality rate of 5-10%, we would be in major trouble right now. I mean, uh, large portions of the world population would succumb, and it would be even more of a disaster, 100-fold more of a disaster than it is already. But so I think it is eventually going to get better, but it'll get better mostly by the susceptibility of the human population becoming less through attrition. I hope I'm wrong, but I think that's how it's going to be. There's a recent paper out of Nature, it was published a few days ago, talking about how they noticed that there was one patient that they followed the genomic sequences of all the bacteria that were being produced within this patient during a prolonged infection. And when they treated this patient with convalescent plasma, the virus was very responsive to it and underwent dynamic population shifts in the genomics of the virus within even one patient. But this is happening on a global scale. And so what we determined is that this virus does respond to selection pressure and does undergo mutation to try to avoid immunogenic control. So I think I'm right, but that's what I think. The virus mutates way too quickly for us to get ahead of it um, on a global scale. Just the logistics of deploying vaccines globally just can't happen fast enough for a virus that mutates this quickly. So I think we're going to live with it. It's going to become an endemic virus globally, and eventually, as the severity of the disease falls off through attrition of susceptible hosts, it'll become less of a problem.